folks. So in today's lesson, we're going to be going over the concepts in the study guide for lesson 2.1 in your Apex Geometry course, titled What is a Triangle? So the first question that we have to do is, in 15 words or fewer, we want to write our own definition of a triangle. So I want to visually think about what a triangle looks like, right? And I know that all those line segments that make up a triangle is going to be on a single plane, so it's going to be a plane figure. In addition, all those line segments come together at a point, right? So there are no line segments that kind of leave a gap to form the triangle. So we know that it's a closed plane figure, and we know that all triangles have three sides. So I'm going to use that as my definition. So a triangle is a closed plane figure with three straight sides. Right? I'm not curving anything, right? All of my sides are going to be straight. So you can skip number 2 in your study guide because it's kind of hard to draw the triangles if you don't have an iPad. And so we're just going to go into straight into question 3, where we are labeling this given triangle with its side, vertex, and angle. So we want to think about the side is the line that connects these points that make up the triangle together. So let me just change that so the background's white. In addition, our vertex is going to be the point at which our two sides meet. So it's right over here. And then our angle is formed by the intersection of those two sides and how far away from the vertex these two sides are from each other, right? So it's measuring how far away from their shared vertex these two sides are from each other. So these three sides are line segments, right? Because these two sides don't go on forever, never, never, that connect the vertices. The vertices are points, right? So they're points at which these sides meet. And then the three angles are pairs of intersecting sides or segments, right? We know that sides are made up of line segments, so we can use segments instead too. All right, let's move on to question 4. So whenever we're talking about triangles, we talk about them in terms of their angles and their sides, and we want to know, just based on common terminology, what it means to be opposite from something, right? So let's say that we're looking at the side that is opposite of angle A. So I'm going to identify angle A, so it's right over here. I want to go straight across from angle A, so I want to draw basically like a line through angle A, and whatever the first side I hit is going to be the side that's opposite to angle A. So imagine a line going straight through this angle. Whatever that first side that you hit of that triangle, that's going to be the opposite side. And then I want to name this side using my two letters or 2 points that make up this line. So I have B and C making up this line. So this is going to be side BC is opposite angle A. And let me just make that slightly smaller so you can see that. Let's look at our next option. So we have angle B, and I want to draw a line straight through this angle, and whatever the first side I hit when I draw that line is going to be my side opposite to that angle. So that's going to be side AC. And then for angle C, right, I want to draw a line straight through this angle, and that first side that I hit is going to be side AB. Okay. So in addition to finding sides that are opposite to angles, we also need to know how to find angles that are between two sides. So let's look at the first question where it says angle blank is included between sides AB and AC. So I want to identify sides AB and AC. So I have AB here and AC here. And I want to identify the angle at where those two sides intersect. And I see that AB and AC are intersecting at this angle A over here. So angle A is included between sides AB and AC. The second one says angle blank is included between sides AB and BC. So I have AB here, BC here, and I see that the angle at which those two sides are intersecting is at angle B. And finally, we have angle blank is included between sides AC and BC. So once again, I just want to look at AC and BC, and I see that they're intersecting at this angle C right over here. Right. Let's move on to question 5. So we want to know how to name triangles as well, and there are a lot of different ways that we can name triangles. The way we name triangles is super important whenever we do congruence proofs later on, because the way you name your triangle is actually how you are kind of writing in verbal form that two triangles are congruent to each other. So we want to know all the different ways that we can name them, because there is just one, right? We always name our triangle by their vertices, and we want to just make sure that we're going in consistent order. So we want to make sure that if I'm starting at D, and if I go to F, I'm going to go to the next point E, right? So I always need 3 letters in order to name this triangle. So I'm going to use that as my first example. So I have D, F, E, right? And usually I would write a little triangle sign before this, but I'm not going to write it because I'm typing it this time. All right, so let's say that I'm starting at angle, at angle D one more time, right? But instead of going clockwise, right, I'm actually going to go counterclockwise this time to get a different combination of vertices. So I have D, E, F, and that can be another name for the triangle. I'm going to start at a different vertex now. So I'm going to start at F. I'm going to go counterclockwise. So I have F, E. I'm going to go counterclockwise. So I'm going to do F, D, E. So that's one more combination of vertices. And this time I'm going to go clockwise. So I have F, E, D, and that's another combination. And now I have, I'm going to start at angle E, right? So I'm going to go clockwise. So I have E, D, F. That's one combination of vertices. And then I can go counterclockwise. So I have E, F, D. Right? All of these are different ways to name this particular triangle. This is really going to matter when we're doing congruence proofs later on. So make sure that you know how to name your triangle depending on what vertex you're starting on. Okay. So let's just review some facts that we know about triangles, right? So they are 2D figures, so they're lying flat on a surface, right? It's not like we can prop them up like a 3D figure. And they are formed by 3 segments, right? Because they have 3 sides that connect 3 non-collinear points, so they're not all on the same line. They have exactly 3 sides and 3 angles and 3 vertices, right? And each side is included between 2 angles and is opposite 1 angle, right? Just like how we talked about in question 4, right? And each angle is between 2 sides and is opposite 1 side, right? And so these last 2 facts over here we covered in question 4, so you can review that too if you need a visual aid for that. Okay, so now that we know some basic facts about triangles, let's actually look at these 3 figures that we see over here and give reasonings for why this is not a triangle. Remember, this is to help us further use our justification skills and our reasoning skills that we're going to need later on when we're doing proofs. So let's look at this figure over here. So first of all, I already noticed that this is not a closed figure just because I see that these 2 sides are not coming together. Okay, so it's not closed. In addition, it has 1, 2, 3, 4, 5 sides. So I know that it cannot be a triangle because I know that triangles only have 3 sides. Let's look at the next one. All right, so if I'm thinking back to my definition of a triangle, I know that I need to be a triangle with 3, in order to be a triangle, I need 3 sides that are straight. And when I look over here, I have no sides that are straight, so all sides are curved. And when I have a triangle, I need all my sides to be straight, right? This is a circle, this is a triangle. And over here, right, I have a closed plane figure with straight sides. However, I have 1, 2, 3, 4 straight sides, right? I have 4 sides instead of 3. So I know that a square cannot be a triangle. So this is just talking about why we use definitions and how we can use definitions to really characterize if something is one thing or not. Okay. So now that we know how to identify and really prove that a figure is a triangle, we can actually sort different kinds of triangles that we see. So we can sort them by angle measure, and then later on we're going to see that we can sort them by side length as well. So whenever we're sorting triangles by angle measures, there are 3 different types of triangles. So we can have an acute triangle, and this means that all the angles are acute in the triangle. So all the angles within the triangle, the interior angles, are going to be less than 90 degrees. We can also have a right triangle, right? And that means that it has one right angle within the triangle, right? It will always only have just one right triangle. It will never have more than one, because if it does, then it kind of negates this other rule that we have about triangles where the interior angles all add up to 180 degrees. And then finally, we can also have an obtuse triangle if we're classifying our triangles by their angles. And that means that there's only one obtuse angle, so one angle that's greater than 90 degrees within the triangle. Once again, for the same kind of reason why there can only be one 90-degree angle in a right triangle, there can only be at most one obtuse angle in a triangle, just because of that rule that the interior angles of a triangle have to add up to 180 degrees. And you will come across that later on. So just like I said, there are 2 main ways of classifying triangles. So you can classify them by their angle measure, which we just covered in question 8, but we can also classify them by their side length. So whenever we have triangles that are classified by their side length, we can classify them as equilateral. And so that just means that all the side lengths in the triangle are going to be of equal length, so they're all going to be congruent, the same size. We can also have an isosceles triangle. Smaller. Okay. And then we can also have something called a scalene triangle. Right. So an isosceles triangle, there are only 2 congruent sides. A scalene triangle has no congruent sides, so they're all different lengths, and an equilateral triangle has 3 congruent sides, so they're all the same length. Right. Now, for equilateral and isosceles triangles, there are actually theorems that we'll come across later that have to do with their angle measure, because they have a special relationship with their angle measures. But for now, just so you know that these definitions talk about their side lengths. So if we're trying to fill out this Venn diagram, right, we see that the overarching circle is going to be all triangles. And so within all triangles, we have these 3 different types of triangles based on their side length, right? So we know that we can have isosceles triangles because they have 2 congruent sides, right? Just make that smaller, right? And then you can be an isosceles triangle and have an extra congruent side as well, so you have 3 congruent sides. So this is going to be our equilateral triangle. And let me just make that a little bit smaller. Oh, let me make that actually a little bit bigger so that you can actually see it. So that smallest circle is going to be equilateral triangle, because only a very small amount of triangles can be equilateral, compared to isosceles triangles where we have just broader options, just because we can have that one side that's not congruent. And then finally, on the flip side, not related to either of these 2 kinds of triangles, because we have no congruent sides at all, is going to be scalene triangles. So let's work on the last page, right? On the last page, we're going to be going over a theorem that you can use in order to actually prove that something is a triangle. So you can use the definition, but then you can also use something called the triangle inequality theorem. And it will tell you that the sum of the lengths of any 2 sides of a triangle is going to be greater than the length of the third side. So this is saying that side 1 plus side 2, if you add those 2 together, it's going to be a greater value than side 3. All right. And so this is another way that you can kind of prove that something can be a triangle, because if it doesn't fulfill the triangle inequality theorem, then it cannot be a triangle, right? So you can use a definition and triangle inequality theorem. So let's see how we can apply the triangle inequality theorem. So whenever we can apply it, we are given 3 possible side lengths. And so we want to identify the greatest side length, right? Let me change the formatting and make this a little bit smaller. Right, so we want to identify the greatest side length. And then we want to find the sum of the other 2 lengths. So we're going to add the other 2 lengths together. Okay, now if this is a triangle, then when we compare the results from step 2 and step 3, if the sum is greater than the lengths can form a triangle. right? This is the whole point of the triangle sum theorem, because sometimes we're given values for sides and we can't actually form a triangle based on those values, right? So let's look at this. We want to determine whether or not these three side lengths that we're given can form a triangle, right? And so the first thing that we want to do is identify the greatest side length. In this case, they're all the same, so it doesn't matter which one I choose. So I'm just going to choose the first one, 3, and I want it to be, I want the other two sides, 3 and 3, right, to be greater than that third side, 3. So let me just evaluate this statement. So I have 3 plus 3, which is 6, and I end up with 6 is greater than 3. So when I think about it, 6 is definitely greater than 3, so this is a triangle. And my reasoning is just because it fulfills the triangle inequality theorem that we just talked about. Okay, let's look at 3, 3, 9. So my largest side is the side length of 9. And so I want to add these other two side lengths, 3 and 3 together, and I want it to be greater than 9. So let's see. I have 3 plus 3, and I want it to be greater than 9. So I do 3 plus 3, which is 6, and let's see if it's greater than 9. So when I think about it, 6 is a smaller number than 9, so this does not fulfill the triangle inequality theorem, so this is not a triangle. Let's look at the last one. So we have 7, 6, and 9. So 9, once again, is my largest side, and I want 7 and 6 when I add them together to be greater than 9. So let me just write that inequality out. So I have 7 plus 6, I want it to be greater than 9. Let me evaluate that statement. So 7 plus 6 is going to be 13, and I want it to be greater than 9. So when I think about it, 13 is a bigger number than 9. 13 is a greater value than 9, so this is a triangle, because it fulfills the triangle inequality theorem. Just make that a little bit smaller. Great. So let's just recap what we talked about in our in this lesson. So we talked about how we can identify triangles based on their measurement, right? So we can identify different types of triangles by their angle measurements and their side lengths. We can also determine if a shape is a triangle based on the triangle inequality theorem, and also based on the definition of a triangle and those key facts that we have about triangles, right? And so hopefully this lesson will help you be prepared for your 3 quizzes under lesson 2.1. And if you have any questions, make sure that you reach out. Good luck.